Hey guys, welcome back to another video. Today we're going to be going over kinematics and calculus and how we can use calculus to derive position, to get velocity, to get acceleration, and what this all means in terms of everything about physics. So firstly, this is the well-known kinematics equation for delta x, and it is missing some things. It's missing t. Okay? So that's our kinematic equation. Now, we know also that velocity equals acceleration times time plus velocity initial. But where does this come from? Now, this is going to be super cool. We know that the slope of the change in position graph, let's say it looks like this, and the derivative or slope is that is going to be our acceleration. So if the slope of this function, the average slope from here to here, right, if it's 5, now our velocity is just going to be a constant 5. But in terms of this, it's changing, so it's going to be boom, 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 boom. So that means our velocity is going to be a constant change of whatever. And then, you may remember from physics, all of this stuff, that means our acceleration is constant. And very rarely is the acceleration not constant. So if you have acceleration is constant, this is linear, and this is quadratic or exponential or whatever, the slopes get less and less. And that's because each time we're finding the slope. And since this is the slope of this is the derivative of this. And that's where we can get these functions. But really, the functions are derived from integration. But for now, we're just going to use derivation to manipulate these functions. So I'm going to erase these graphs, and then I'll give you an example. If I tell you acceleration is 5, okay? Well, let me go over this. So, if we implicitly differentiate this function here, delta x, excuse me, if we implicitly differentiate this x, and we know it equals 1/2 at squared plus v initial t plus x initial, and we derive this, what's it going to be? It's going to be, bring the 2 down, at plus v initial plus 0, and this becomes our velocity function. And it gets even cooler when you say, oh, what's the derivative of this? Well, that's going to be acceleration. Acceleration is derivative of this, acceleration plus 0 plus 0. So acceleration is acceleration. And then if I give you acceleration is 5, you'll be able to integrate and work backwards and backwards all the way to your x function. So let's go over a quick little example with this. So basically, if I say that the delta x is equal to, with an acceleration of 10 t squared, you'd plug that in, and I'll say initial velocity 2, plug in your 2 t, and then initial position is 0, and then I say at time t equals 2, comma, delta x equals 6. You plug those in, and you get 6 equals 5t squared plus 2 times t. Plug in 2 as well, and then you're able to find your initial initial position from that. And then you can use this to derive this one, and get your velocity and acceleration. But that's all we're going to go over for this video.